having done FD, we can continue on our playlist by doing collision. We are told down the description that Daddy told me about a cool MD5 hash collision today. I want to do something like that too. So we are given a link to log in, the password. So we can see that we are getting a unknown terminal error. So we can solve this by, we have two files here. One is a COL, a binary that has a set UID bit set. It is owned by COL, but we can execute it since we are in that group. When you execute it, I bet it's running as COL. So we also have a flag that can only be read by COL, and then a source code that is owned by root, but we can read it. So let's read the source code. You can see a strange function there, and then a long hash code. Continuing down, we can see we need to enter exactly 2 arguments, otherwise it will error out with this message. Then it is checking the length of our second argument. If it's not 20 bytes, it errors out with that message. The other thing is that it checks if the hash code equals to the return of this function. So it gives our input as the argument to this function. We can see the message that is erroring out if we don't give it an argument. We can try some gibberish like 20 A's. I didn't count that, but you can use the alias I showed you on the last video we did called dump. So I can just dump 20, so those are 20 A's. We are told wrong passcode. So if this is not true, we are told the wrong passcode. So how will we get this true? We know that the loop is going for 5 times. It's looping for 5 times. The hash code is this one, and then it is taking our input and adding it to itself. So it is taking our input as integer pointers. If you have learned about pointers, you know that pointers are 4 bytes long. So it's taking 4 bytes of our input for 5 times and adding it together. So it's simple maths. 4 times 5 is 20 because you are looping 5 times. So what you can do here is take this value here and maybe divide it by 5 times and then give it as the input. And we get that this number is not completely divisible by 5. So what we can do here, we will improvise, multiply that by 4, then the result we subtracted from the number, and we get this. So basically you can multiply this and then add this to achieve the same number. So that is what we will be doing. The next thing we can try to do is check the properties of the COL binary. You can see that it is an ELF, so executable linkable file. That is a 32-bit least significant byte executable. That is nice. We can also see that it's not stripped, so basically it has all the symbol functions and all that. It is dynamically linked, so basically it has the shared objects. If basically you can check it using this command, you can see the shared objects there. This is the dynamic linker, and this is the libc. So how we will want to solve this, because it is a least significant byte, we want our least significant byte to be entered first. So how we do that in Python, we need to pack the bytes. So I'll use struct. So I was gonna use struct, and I'm thinking this is not a wise idea. I want to write a one-liner, so let's see. So we needed these values, that's why I have redone that, so that you can write a one-liner. So we want those to be 4 multiplied by 4, then we add our next bytes. then we can close. What this is doing is like we are conflicting this because of the quotes, so let's change that. And you can see some gibberish. This is nice because if you can like see that, we can try using another program like XXD and we'll see the bytes, so that's nice. So we can try this on the actual server, and then the way we execute this on the shell is like using the backtricks, and you can see that we get the flag. So I want to write a simple script for this so that we can like have a solve script. Nice. So I use another layers to like copy a script that I have, so I'll just call it COL. I'll tell it the binary name is COL, and then it will copy a script for me. So let's change that to I386. The next thing is that we know the username is COL. Yeah, we didn't need those, so we are left with what we need. We know the username, we know the host, this the port, and this the password. The next thing we need to do is like when we drop there, we want to execute COL, and we want to specify our payload on the arguments that are being passed to the program. So let's do just that. So the way we pack bytes in Pwntools, we use like P32 or P64. Yeah, so let's see. Yeah, and we can see we get the flag back. So to make this script efficient, we can like change the p.interactive to something else, whereby we like close the server, closing the resources. So what I'm doing is like I'm using an inbuilt function log.info to like output the flag. I'm using p.receive to like receive the bytes from the executable as it runs. The next thing I'm going to do is like close the server. And yeah, we get flag art, and now this is our flag. See you next time.